today we're going to be talking about composition of functions. This is really just evaluating functions by using the output of one function as the input of another. So let's talk about notation first. You might see something that looks like this. The way we say this is f of g of x, or you might see it this way, with a circle in the middle, and that just means the same exact thing, but we say this one as f following g of x. And all this means is that we're going to take the g function, we evaluate g of x, and use that as the input for f of x. Okay, that's all there is to it. So you start from the inside and work your way to the outside. It's really best to look at some examples to see how this works. So let me slide this down a little bit here. So let's say I asked you to do f of g of 2. What this means is you're going to first find g of 2. Our g function is right here up on top. G of 2, 1/2 times 2 is 1. 1 plus 4 is 5. That's what g of 2 is, and now we're going to use that as our input into the f function. And now we find f of 5. Our f function is right here. 2 times 5 is 10. 10 minus 9 is 1. Okay, so that's it. In the end, f of g of 2 equals 1. Okay. Let's say, instead of using numbers, that we actually just use our functions, and we can do f of g of x again. Okay, so again, what this means is you're going to take the g function and replace it, or use its input for f. So now we're going to evaluate f at our g function, which is 1/2 x plus 4. Okay, so now anywhere you see x in the f function, we're going to replace it with our new input. And again, our f function here is 2x minus 9. So now 2, we're replacing x with our output from g of x, and then plus 9. And now you just work it out. Okay, so let's take a look. 2 times 1/2 would give us 1x, or just x. 2 times 4 is 8, plus 9. Our final answer here, x plus 17. Okay? Now, f of g of x and g of f of x are not commutative. Okay, so just because f of g of x is x plus 17, that does not mean that g of f of x is x plus 17. Let's look at some more examples here, okay? But I do want to make a specific note here. One more thing before we move on is that, again, f of g of x does not always equal g of f of x. Sometimes it does, okay? We'll investigate that next week. But it's not always that way. All right, so let's look at some examples, some more examples. We have some functions here. So let's say that we wanted to do f of g of x. Okay, we'll try another algebraic one. This means we're going to take our g function, which is 2x plus 3 minus 3, and now input that into input that into f. Let me just fix that there. Okay, so again, anywhere you see x, we are replacing it with 2x minus 3. So we have x squared, 2x minus 3 squared minus 2x minus 3. Be really careful here when you're asked to square binomials. You have to remember to FOIL. So we would get 4x squared minus 12x plus 9. Now distribute this negative. Minus 2x plus 3. Again, also always be careful when you're subtracting a quantity. Now just combine like terms. 4x squared minus 14x plus 12. Okay. All right, what about, let's just try a couple more here. F following h of, I don't know, let's say 2. So now this means, if it helps, you can rewrite it. F following h is the same as f of h of 2. Okay? So let's evaluate first h of 2. H of 2 is 1 over x plus 6, so that will give us 1/8. And now we want to evaluate f at 1/8. So that means anywhere we see an x, we're going to put in 1/8. So we have 1/8 squared minus 1/8. Okay, and if we work that out, 1/64 minus 1/8. And you can work that out to get your final solution. Okay? All right. I think that pretty much wraps it up. You have some practice problems to work on, and if you have any questions, we will take a look at them tomorrow. See you later.